We can use this simulation to show how the constituents of an atom, protons, neutrons, and electrons, can be used to build up the atoms in the periodic table. The constituents, of course, are protons, and protons have a mass of 1 atomic mass unit and a charge of +1. Neutrons, to be found in the nucleus, have a mass of 1 atomic mass unit, but they're neutral. They do not carry a charge. Electrons are very, very light, virtually massless. In fact, we ignore electrons when working out the mass of an atom. They're virtually massless, but they carry a charge of -1. So protons are to be found in the nucleus, and hydrogen, the first and simplest atom, has 1 proton in the nucleus. You notice up here it says plus ion, and that essentially means that when we make up ions, we want them to be neutral. So the number of protons in the nucleus, the atomic number, 1, is the same as the number of electrons around the nucleus in the atom. Now this picture of an atom is not to scale, but it'll do for the purposes of this simulation here. Now we've got 1 proton in the nucleus and 1 electron whipping around the nucleus, and the exact manner in which it does that we're not going to pay much attention to right now. Just suffice it to say that the electrons exist outside the nucleus. Now we have neutrons. What do we do with these neutrons? Well, in the case of hydrogen, this hydrogen atom is itself stable, as it says right here. But there's nothing to stop neutrons from being added to it. If we put a neutron into the nucleus of this hydrogen atom, it now has a mass of 2. And that hydrogen is only different from the previous hydrogen by the fact that it is heavier. The first hydrogen, hydrogen 1, and this is hydrogen 2, and they are called isotopes. So isotopes are atoms with the same number of protons in the nucleus but different number of neutrons. Now, how many neutrons can we go on adding? Well, let's see. Here we go. We'll add a third one in. Now, that's unstable. This is the first unstable isotope of hydrogen, and we can go over here, and there's the symbol for it, and we can see the mass number for it is 3, and the net charge is 0 because the number of protons and the number of electrons are equal. Now, this isotope does exist in nature, but not very much. So the minute the nucleus becomes unstable, there's no point in adding any more neutrons into the nucleus because it would just become more and more and more unstable. In fact, this isotope of hydrogen does not exist. Okay, so let's remove the neutrons. All right, that's hydrogen. Element number 2 on the periodic table is helium. And helium has 2 protons in the nucleus. And now you notice right away it's unstable, and that's because the minute you have 2 neutrons, you must have, the minute you have 2 protons, you must have a neutron to stabilize the nucleus. And generally speaking, the minimum number of neutrons is at least the same as the number of protons. Now it's a plus ion because there are 2 protons but only 1 electron, so we'll add 1 electron, and there it goes. So now we have a helium atom, and this is a stable helium atom. Once again, we can do the same thing with the neutrons. We can go on adding neutrons. The minute we add 1 neutron to it, it's unstable. We add another one to it, and it's still unstable. So we would expect there to be only 1, perhaps 2 isotopes of helium in nature. All right, so that was helium, atomic number 2. Next is lithium, atomic number 3. Atomic number 3 means 3 protons in the nucleus. Okay, right away the nucleus becomes unstable, so we're going to put a neutron in to stabilize it. And now we've got to add an electron. Now you notice this electron went into a different ring. This is the representation of the energy levels of the atom. This first level here was filled with the completion of the first row of the periodic table. This next level will go on filling until we come to neon, which is 8 atoms away. So this is lithium, atomic number 3, with 3 neutrons. Let's see if we can add another neutron. There's 4 neutrons, so we now have an isotope of lithium, which has a mass number of 7 as opposed to the original 6. And can we add another neutron? Becomes unstable. So we know at least there are 2 isotopes of lithium, lithium-6 and lithium-7. So we'll take those neutrons that we added away. So now we have 3 protons and 3 neutrons. Now that's for lithium. The next one is beryllium, atomic number 4. So we add another proton into the nucleus. It's unstable. We put a neutron, and that's still unstable. Now that becomes stable. So here, in this particular case, it takes the 5 neutrons to stabilize the nucleus of beryllium, which has 4 protons in it. It is a +1 ion, which means we need to add an electron out here in order to make the atom neutral. Well, we can go across one by one, but we're going to skip right up to neon here. So neon is atomic number 10, which means it has 10 protons in the nucleus. We've got 4 so far, and I'm going to take away one of these neutrons and just, okay, 4, 5, 6, 7, 8, 9. Okay, so there's 10 protons. There are 4 neutrons there already for 5, 6, 7, 8, 9, and 10. Okay, now we have a stable nucleus. This is neon, and this isotope of neon has a mass of 20. Let's see if we can add more neutrons to it. Oh, there's another one that's stable, so that's neon with a mass number of 21. So that's another isotope there. And here, a third isotope, which is stable. That's neon 22. And let's see what happens if we try this. It becomes unstable. So we know that there are at least 3 isotopes of neon that are stable. Neon 20, 21, and 22. Okay, I'm going to grab that neutron. Now, it's a positive ion because the number of neutrons, or the number of protons rather, and the number of electrons is not equal. So we need to add 6 electrons to come up with a total of 10. Now you notice these electrons are zipping off to their own particular spaces, and we won't worry about what that means right now. Suffice it to say that we have now created neon, a neutral atom, 10 protons, 10 electrons, and anywhere from 10 to 12 neutrons in the nucleus. And notice we have also filled this ring here. So we've filled another energy level, and we're at the end of this row of the periodic table. This simulation also comes with a game you can play to put your skills to work, and the simulation is just included under this.